Welcome to Astronomy Daily, your go-to podcast for the latest updates in space and astronomy. I'm your host, Anna, and today's episode is packed with riveting news and discoveries. We'll delve into the latest findings from NASA's Parker Solar Probe as it unravels the mysteries of the sun's extreme corona heat. Then, we'll discuss the discovery of a new Earth-sized exoplanet, Gliese 12b, that promises thrilling potential for future study. We'll also explore how organic macromolecules form rapidly in star-forming regions, shedding light on the origins of life's building blocks. Finally, we'll look at virtual engagement opportunities for Northrop Grumman's upcoming resupply mission to the International Space Station. Let's get started. NASA invites the public to engage virtually with Northrop Grumman's upcoming 21st commercial resupply mission to the International Space Station. Scheduled for August 10, 2024, at 8:31 p.m. EDT, the launch will take place from NASA's Wallops Flight Facility on Wallops Island, Virginia. The event promises to be a spectacular showcase of innovation and collaboration. This mission is particularly special because it honors the late NASA astronaut Laurel Clark, naming the Cygnus spacecraft the SS Laurel Clark in her memory. Clark was a mission specialist on the tragic space shuttle Columbia's STS-107 mission, and this tribute underscores the spirit of exploration and sacrifice that drives space missions. Northrop Grumman's Cygnus spacecraft, carried into orbit by an Antares rocket, will deliver over 8,200 pounds of science experiments, research materials, supplies, and hardware to support the work of Expedition 69 astronauts aboard the space station. This critical mission will help sustain the continuous human presence in low Earth orbit. The virtual engagement program offers a unique opportunity for space enthusiasts to be part of this exciting event. By registering as a virtual guest, participants will receive curated launch resources and notifications about interactive opportunities. As a bonus, virtual attendees will receive a commemorative virtual guest passport stamp post-launch, a small token of involvement in this significant milestone. Participation in the virtual guest program is free and open to the public. This initiative aims to make space exploration accessible to everyone, fostering a sense of global community and shared curiosity about the universe. By bringing the excitement of a live launch into homes around the world, NASA continues to inspire the next generation of scientists, engineers, and dreamers. As the countdown begins, don't miss out on being part of this momentous occasion. Register now to engage in this spectacular virtual experience and witness firsthand the brilliance and dedication that propels our journey into space. The Parker Solar Probe has made groundbreaking discoveries about the sun's corona, challenging long-held beliefs and opening new avenues for understanding solar dynamics. Traditionally, scientists suggested that S-shaped magnetic field bends, or switchbacks, contributed to the extreme heat of the corona. These switchbacks, observed in the solar wind, were thought to be the source of the sun's outer atmosphere's immense temperatures, which can be up to 200 times hotter than its surface. However, the Parker Solar Probe's recent findings have turned this theory on its head. As it ventured closer to the sun, the probe observed that while these magnetic switchbacks are common in the solar wind near the sun, they are notably absent in the corona itself. This suggests that these bends are not the culprits behind the corona's scorching heat. So if switchbacks aren't responsible, what is? The absence of these magnetic bends in the corona hints at the existence of other, yet-to-be-discovered mechanisms that could be driving the heating process. This discovery has set the stage for further research to unveil what exactly causes the sun's outer atmosphere to defy the laws of physics. As the Parker Solar Probe continues its mission, it aims to collect more data, especially during its upcoming trips closer to the sun. These future observations will help scientists test new hypotheses and potentially identify other phenomena that could explain the corona's extreme temperatures. This ongoing research is crucial because understanding the corona is essential for comprehending solar wind, space weather, and their impacts on our solar system. This revelation from the Parker Solar Probe underscores the importance of continual exploration and data collection in unraveling the mysteries of our solar system. Each new discovery not only demystifies the sun's behavior, but also brings us a step closer to predicting and mitigating the effects of solar activities on Earth. In an exciting breakthrough for astronomy and the search for extraterrestrial life, scientists have announced the discovery of Gliese 12b, a temperate, Earth-sized exoplanet situated just 40 light-years away. This might sound like a great distance, but in terms of the cosmos, it's a mere stone's throw away, a relatively neighborly 378 trillion kilometers. Gliese 12b was discovered by an international team of researchers, including key players from McGill University and Western University. This effort was part of the Infrared Doppler Subaru Strategic Program, which focuses on finding planets within the habitable zones of red dwarf stars. Red dwarfs are smaller, cooler, and more abundant compared to stars like our Sun, making them prime candidates in the ongoing quest to find life beyond Earth. The planet orbits its host star, Gliese 12, which is a red dwarf. Unlike more active red dwarfs that exhibit frequent and intense stellar flares, potentially harmful to any orbiting planets, Gliese 12 is unusually inactive. This translates to less harmful radiation, creating a more stable environment for Gliese 12b, thereby increasing the planet's chances of being habitable. What makes Gliese 12b particularly intriguing is its location within the star's habitable zone, often referred to as the Goldilocks zone. This is the region around a star where conditions are just right for liquid water to exist on a planet's surface, neither too hot nor too cold. Given that water is essential for life as we know it, this discovery is a significant step forward in the search for potentially habitable worlds. Although more observations and modeling are needed to confirm the presence of liquid water or any biosignatures, the planet's Earth-like size and location within this habitable zone make it a tantalizing subject for further study. Indeed, Gliese 12b's proximity allows for detailed analysis of its atmosphere and other characteristics. One particularly useful method for studying such planets is atmospheric transmission spectroscopy. This technique involves examining the starlight that passes through a planet's atmosphere during transit. By analyzing the changes in the light's spectra, scientists can infer the atmospheric composition, looking for gases like oxygen, water vapor, methane, and carbon dioxide. The presence of these gases could indicate biological processes. The discovery of Gliese 12b is thrilling, not just for its immediate scientific implications, but also for its potential to deepen our understanding of what makes a planet habitable. Future telescopes, including the James Webb Space Telescope and ground-based extremely large telescopes, will be instrumental in studying the planet's atmosphere and surface conditions more thoroughly. As we continue to explore the cosmos, each new discovery like Gliese 12b brings us one step closer to answering the age-old question: are we alone in the universe? For now, Gliese 12b stands as a beacon of hope and curiosity, inviting us to learn more about the possibilities that lie beyond our own solar system. In a fascinating discovery, an international team of researchers led by scientists from the Netherlands has shed light on how organic macromolecules form in the disks of gas and dust enveloping young stars. By employing observation-based computer models, the team uncovered that dust traps, which are regions where dust and ice accumulate, can play a pivotal role in this process. These dust traps are not stationary. Instead, they exhibit vertical movement, constantly cycling material within the young star's disk. When these dust particles, laden with simple ices, are exposed to intense starlight, they undergo significant chemical transformations. The researchers found that this irradiation triggers the formation of complex organic molecules, up to hundreds of atoms in size, akin to substances like soot and graphene. What's truly remarkable is the speed at which this process occurs. Under optimal conditions, macromolecules can form within just a few decades. This rapid formation provides a new perspective on how the building blocks of life could develop in star-forming regions, suggesting that the ingredients for life might be much more common in the universe than previously thought. The study's model, grounded in a combination of laboratory research and observational data, demonstrates that the heavy irradiation from stellar light in these dust traps can effectively kickstart the creation of large, complex molecules. This new understanding enriches our knowledge of the chemical processes at work in protoplanetary disks and offers insights into the early stages of planetary system formation. One of the leading voices in this research, Niels Ligterink, highlighted the importance of considering the effects of intense radiation on complex chemical processes. Traditionally, scientists have focused on smaller organic molecules, but this study underscores the significance of larger macromolecules in the composition of chondrites, the primitive meteorites rich in organic compounds. Nienke van der Merel, another co-author, voiced her enthusiasm for the study, drawing attention to the unique intersection of astrochemistry, observational astronomy, laboratory work, and the study of meteorites. This interdisciplinary approach has allowed researchers to develop a comprehensive model explaining how large organic molecules can form under certain conditions in young star systems. Going forward, the research team aims to explore how different types of dust traps respond to varying levels of radiation and dust motion. This line of investigation will help scientists better understand the potential for life around different types of stars and exoplanets, broadening our grasp of where and how life could arise in the universe. This discovery not only enhances our comprehension of the origin of macromolecules crucial for life, but also opens up new avenues for studying the early chemical environments of emerging planetary systems. It adds another piece to the intricate puzzle of how life's building blocks are assembled in the cosmos. Thank you for tuning in to this episode of Astronomy Daily. I'm Anna, and it was a pleasure to bring you the latest in astronomical discoveries. Don't forget to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter, catch up on all the latest space and astronomy news with our constantly updating newsfeed, and listen to all our back episodes. You can also find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. Until next time, keep looking up.